Okay, so regarding, okay, before I proceed, because I have received the question from Faiza. She asked me regarding on if let's say the objective related to relationship, so which analysis that she should use. Okay, it's actually again you need to go back to your objective. Okay, either you just want to look for the relationship between the variables. Is that the relationship is based on just correlation or regression? So the researcher need to decide that one. Okay, so either you want to use correlation or regression to answer your hypothesis depends on depends on the researcher. But if let's say your objective stated that you want to check for the best predictor, directly you said that directly the analysis should be regression. Okay, but if let's say you just state that to determine the relationship between your IV and DV, okay, your analysis can be either correlation or regression. So you need to decide lah either one, or you want to report both. But for your hypothesis test, you need to select either one. Either the hypothesis testing is based on correlation or regression.
Alright, noted.
Yeah. Okay, so but if you ask me which one better, my answer is regression. Okay, because regression can determine the relationship. Okay, it can be words. Okay, and at the same time,
क्वेश्चन रेज किया हुआ है, आर्टिकल की वैलिडिटी खराब हो गई है।
alamak.
अब ये देखो क्रॉस प्रोडक्ट है ना, ये बड़ा ये तुमने अब पहला अगर आइटम देखें तो ये लोड जो ये वाला आइटम है, ये लोड इस पे भी कर रहा है, ये लोड बाकियों पे कम कर रहा है तो ठीक है, ये लोड इस पे कर रहा है बाकियों पे, ये देखो 0.8 तो 0.8 इसका डिफरेंस है, ये भी सही तुमने किया है।
Nggak doa tu.
Alamak.
Betul seru.
Hari Jumaat elok berdoa.
Kejut.
Muhabbatin.
Okay, muhabbatin. Okay, so because if a correlation, you just indicate the relationship. The relationship that you can indicate is based on the magnitude and the direction, but you cannot say your IV influence your DV. Okay, in terms of the flow, you cannot say even the relationship is positive, but you cannot certainly say that your IV influence your DV. You cannot say that. So that is the restriction of the correlation. So meaning that your finding, if you just stop at correlation, your findings is hanging. Okay, you just can say that your IV and DV is positively associated.
Okay.
Itu dia punya restriction ataupun limitation when you use correlation. Okay, but if let's say you use regression, you can report the magnitude, the direction, as well as the flow of the relationship, which is from IV to DV. You can confirm that flow. Okay, because in correlation we cannot confirm either the direction is from IV to DV or from DV to IV. Kita tak boleh confirm that one. Okay?
Okay.
Okay, so we proceed to our topic. Okay, so regarding our topic last Tuesday, it's actually just nak confess sikit lah. Actually, the previous slide, I have to do it dekat masa dia sangat suntuk sebabnya the last year slide that I use missing somewhere. Masa saya tengah cuci laptop, deletekan file tu, saya terdelete keseluruhan file lecture note saya. So that's why ada banyak benda yang missing. So this one yang betul-betul lah saya cari balik, terpaksa minta dengan student balik, jumpalah balik. Okay. So this one saya rasa sangat complete sikit lah. Okay, so based on our research question last week. Okay. The question, mana dah soalan dia tu? This one. So this is the question that we want to answer. Okay. So we have the first question is to test the mean effect of the studied variable, in which in this study we have two independent variables, two categorical independent variable, and then second question is you need to state the null and research hypothesis for the interaction between the two IVs. Okay, and then lastly prepare your prepare your report according to the APA style. Sekejap. Nak button lagi pula ni. Okay. So I thought here we are done. So we are just last Tuesday we just start here, right? Okay, are you ready with your data set? We still use the last data set that we use in on Tuesday. You ready with your data set? This one you need to really have your data set. Because dia punya step tu sangat ni sikit. Ada
Whitening tu kan doktor?
Again?
Whitening punya data tu kan?
Deterjen.
Okay.
Ya, Azizi tak kata deterjen tu. Okay, ready Okay, to run the analysis again. Okay, you click analyze, create general linear model and then click univariate. Analyze general linear model and univariate. Okay, and then once this box appear, okay, you choose your DV, okay, in which whiteness. Okay, choose your DV whiteness and locate under the dependent variable column. Okay, under dependent variable box, and then you choose another two of your IVs, detergent and water temperature, and then locate it under fixed factor. Okay, and then you click plots. Okay, click plots. Okay, and then locate this one. Okay, in our case, it is based on 2 by 2 factorial ANOVA. So you can locate either detergent or water, either it is a horizontal axis or separate line. Because last Tuesday, I remember Ruzaimi asked me, is it possible to locate the IV or DV whenever we want? Right, Azizi, apa tu Ruzaimi betul kan?
Betul.
So basically macam ni lah.
Betul.
Kan, ada lagi satu soalan kot. Yang lain kot. Ada satu section lain kot yang Ruzaimi tanya, tak apa. Nanti saya explain. Okay.
Ya, yang itu yang regression.
Regression okay.
Ya, soalan lain tu yang regression.
Okay, salah. Okay, so in here, okay, untuk yang IV ni, okay, yang untuk horizontal axis ni biasanya we locate we locate the variable with more levels at the horizontal axis. Okay, but in this case, because it is 2 by 2, so you can select either one. Either you want to locate the detergent or water variable under horizontal axis. You can choose either one. But if let's say in your study you have one IV that has 3 or 4 variables, meaning that you need to choose that variable, that IV, and then locate it under the horizontal axis. Okay, horizontal axis is the for the IV that has more level of that has more levels. Okay, and then now you locate detergent done, and then locate water under the separate lines. Okay, and then you click add. Okay, click add. Okay, so after you click add, so your the interaction will be the interaction variable created, and then now you click continue. Okay, so now you click option under the main windows. You click option. Okay, this one I use this lecture ni dia pakai I use version 22 if I'm not mistaken. Okay, this one is version 22. So for those who use version 25, okay, you choose apa last week? ESM.
EM means doktor.
Yeah, EM means betul. You use that one. Okay. So now EM okay, under EM means you choose EM means. Now you select the 3 variable, detergent, water, and the interaction of detergent and water, and then locate it under display means 4. Okay, locate it here. Okay, and then you tick for compare main effect. Tick for compare main effects, and then this one automatically will be activated. Okay, and then now you for those who use Ibm Spss version 25 and above, now you click option. Okay, click option and then this these items appear correct. Okay, and then you tick for descriptive statistics, estimates of effect size, and homogeneity test.
طب اعملي هيك فكرة.
Ni kena
يعني هلا افتحوا لنا
okay. So once done, you click continue. No problem Semua okay So far so good? Okay, then click continue. Okay, and then now you click okay. Okay. For our case, just click OK. But this case, if let's say your analysis has one of your IVs has more than 3 groups, okay, this is the special case. If let's say one of your IV has more than 3 groups, okay, you need to click post hoc. But in this case, we do not have any independence with more than 3 groups. Both of our independent variables have 2 groups only. Okay, so in this special case, if one of your IVs has more than 3 groups, 3 or more, okay, you need to click the post hoc, and then under post hoc, you need to you need to choose your factor here, okay, factor here, and do you need to locate your variables, and then you need to tick for LSD. Okay, only then you click your, only then you tick for continue. Okay. Itu untuk case yang ada variable dengan 3 level. Sebab case kita tak ada. Case kita 2 sahaja. Okay, done So, your result already appear. So, this is the first table. Second table. So, we have the between subject factor and then descriptive statistic. Okay, so for in here, in descriptive table, okay, we can check for the mean. Okay, so the mean here, the mean and standard deviation. So this one we need to report in our final report letter. Okay, and then yalah ni simple je, ini descriptive. Okay, the second one is the Levin test of equality of error. Okay, so this one is to check for your assumption. Okay, homogeneity of variance assumption. Okay, so this one similar, no problem, should be. Okay, and then this is the main output. So I thought last time I already explained about this table. Okay, so in this table it present you, the first thing is, kenapa dia start dengan nombor 2? Okay, the first thing is the main effect for detergent. Okay, so in here, okay, our concern is F value, significant value, and partial eta square. Okay, so these are the main function of the the main purpose of this table. So based on for detergent, okay, we report the F value and significant value. Okay, according to APA table, when you report your findings, okay, when you report your findings, you need to make sure that you report both F and significant F value. Okay, you need to report both F and significant F value. Do not just report the significant value. Okay, it is not enough. You need to report both F and significant F, even though when we made the decision, the decision is based on the significant value. But in reporting, make sure you report both F and significant F. Okay, so in this case, since the significant value here is larger than alpha, then therefore we reject lah. Therefore we can say that the detergent does do not has a significant main effect towards clothes whiteness. Okay, and then for water this one, okay, for water, since the significant value is lesser than alpha 0.05, therefore we can conclude that there is a significant main effect of detergent. Of water. Okay, and then in terms of the interaction here, okay, in terms of the interaction, based on the significant value, we also can conclude that there is no significant interaction effect of detergent and water towards clothes whiteness. Okay, then in terms of the effect size, you can refer to this table to interpret your effect size. Okay, so the next table is the further explanation regarding our findings on the main effect and interaction effect. Okay, so this one is related to detergent, the first our first IV. Okay, so here it indicated that similar to our main table, the result here also indicated that there is no significant difference between Mighty Good and Super Matte brand in terms of the cloth whiteness. Okay, so it is similar. Okay, and then for water, okay, earlier table indicated that there is a significant main effect. Okay, so it is reconfirmed in this table, in which based on the pairwise comparison table, we can say that there is a significant difference between hot and cold water. Okay, similar. Ni isu kita dekat sini. Okay, last Tuesday we stop here, right? So this is the result. Okay, actually we do not use this confidence interval. Okay, so we need another one step. Okay, we need another step to further check our findings on the interaction. Okay, to do this, okay, we go back to our data set. Okay, go back to our data set. Okay, now in your data set, you need to click Analyze General Linear Model and then click Univariate. Okay, Analyze General Linear Model and Univariate. Okay, and then this box again appear, this window appear again. Okay, now sebab I thought everything's already in place. Okay, in terms of your DV and then your IV. Okay, now you just need to click Paste. Just click Paste. Okay, just click this button. Okay, and then it's appear your syntax windows appear. This is your syntax window, Okay, in your syntax window, you need to type compare. You just type this sentence here. Dekat line ni. Line EM means here. Okay, you type compare detergent. Okay, you just type this one without this apa tu? Without this hyphen Yeah, click type compare detergent. Compare bracket, open bracket, detergent and close bracket.
Doctor, meaning EM means equal to compare.
No. This one is okay. You just add another.
Oh, maintain.
Yes, just add another.
Okay. Right, thank you.
Done. Compare bracket detergent.
All right.
Okay. Once
Compare
done.
detergent.
Okay, once done. Okay, so means that it should appear like this. It should appear like this. This one. You have this tables, interaction between detergent and water, and then you compare detergent. Okay, it should appear like this. Okay, and then you click this one. This arrow, this green arrow. Just click this green arrow. Okay, click this button on. Okay, and then done. Okay, your overall result appear again. Correct? Appear tak? Keluar tak? Okay. Now we go again to the result for number 3, the interaction between detergent and water. Now the pairwise comparisons appear, right? The pairwise comparison table appear. So based on the table, it's reconfirm our earlier finding that there is no significant difference, significant interaction effect, right? Sama lah kan? Right? In hot water, detergent, right? So it is still, it is reconfirmed that there is no significant difference, right? Inilah. So kita punya confusion itu kat sini je lah. Okay. So now it's appear and then it's reconfirm our overall findings that there is none of the pairs of the between water temperature and detergent brands that's significantly different. Okay. Okay. So then we set our alpha. Okay. This one decision. The rest should be similar, but this lecture note is more comprehensive compared to the last Tuesday. Okay, because this one is based on based on the question. Okay. Okay, so this one done. Quiet ni done. Sama ni. Tak ada masalah, should be okay. Okay, in terms of the APA presentation, please use this format. Okay, in terms of the APA presentation, use this format. Do not use the last time. Okay. So you need to report your sum square because sum square if necessary later you need to calculate for the effect size. But in this case, I just give you the result for effect size. Okay, so you just need to report your sum square, degree of freedom, okay, mean square, F value, and then the significant F. Okay, and then this is the descriptive finding. Okay, the mean the mean for hot the mean for your IVs, okay, and then this plot as well, okay. This is the interpretation. In terms of the interpretation, done. So any question? Lega rasa boleh settlekan benda ni. Any question? Very clear? Clear?
Clearer.
Alhamdulillah. So we stop untuk kali ni kita stop kat sini So shall we proceed to correlation and regression? Okay. Okay, so this is the correlation. So in this topic, okay, this is the LO. Okay, we to identify the two types of analysis to determine the association between the IV and then the DB. To determine the requirement to run the Pearson product moment correlation, PPMC referring to Pearson product moment correlation, and Spearman's rank order correlation. Okay, and then you to run the analysis in Ibm Spss, report the result according to the 6 APA style. Okay, so this one we skip lah. Okay, the correlation we use to describe the strength and the direction of the linear relationship between the two or more variables. Okay, and then we use the symbol R. Okay, in general we use R, but it can be R represent the Pearson product moment correlation. RS represent the Spearman rank order correlation. Okay, and then the value of R, okay, can range from +1 to -1. Okay, the minimum can be 0, the highest can be 1. Okay, plus minus just indicate the direction of the association. Okay, plus minus do not indicate the value, but it just indicate the direction of the relationship. Either the relationship is negative or positive. Okay, in terms of the magnitude, okay, we refer to the value. Okay, if let's say the value is 0, meaning that there is no relationship. Okay, but if let's say the value is 0.8, okay, we can indicate there is a relationship. Okay, but we can determine the level based on the cut-off point given by Cohen and Guilford letter. Okay, so this one done. Okay, this is the example based on the scatter plot. Okay, this is the example of zero correlation in which the dot is scattered everywhere. Okay, the dot scattered everywhere. But if let's say the dot is somehow scattered in straight line, so we can see that there is a relationship actually here. Okay, for the first scatter plot here. Okay, next this one negative. Okay, because the direction is towards ke bawah. Okay. Okay, and then this is the brief lah. Okay, it's developed by Carl S. Pearson. Okay, so that's why the name is Pearson. Tahulah siapa-siapa boleh come out dengan new statistical equation, so they may put their name. Okay. Okay, so Pearson product moment correlation. Correlation is a Pearson product moment correlation. Okay, Pearson product moment correlation measured by R. Okay, we use the symbol R. Okay, and then it is a parametric statistics. Okay, the purpose is to determine the association or the relationship between two variables. Okay. Okay, and then the requirement is both both your DV and IB must be in interval or ratio scale of measurement. Okay. And then in terms of the assumption, there are only two assumptions that must be fulfilled. The first one, the score for both IB and DV must be normally distributed, meaning that you need to check for the normality assumption for both IB and DV. Okay, and then the case also must be collected from the sample random sampling, from the random sample technique. Okay. Please let me know kalau saya terlalu cepat. Okay, so in this topic, what we are going to cover is the Pearson product moment correlation in terms of the descriptive interpretation, which include how we are going to extract the R value, and then we interpret the direction based on the R value. We interpret the direction of the relationship, either it is positive, negative, or no relationship. And then we interpret the strength of the relationship based on Guilford rule of thumb, or you also can use the Cohen. Okay, and then for the inferential part, okay, we will test the relationship between your IB and DV. Okay, and then you need to state the hypothesis for null and research hypothesis. You need to report the R value, determine the alpha, and then make the decision and interpretation, and lastly present and report. Okay, this one ni boleh laju lah ni. Salah ni. Okay, to state the hypothesis, there are two ways. Either you want to state your hypothesis according to statistical method. So based on statistic, this one lah. Okay, null hypothesis, rho equals to 0. Research hypothesis, either rho not equal to 0, or rho larger than 0, or rho lower than 0. But in practical, we state our research hypothesis like this. Okay, either there is no correlation between IB and DV. Okay, and then our research hypothesis will be there is a significant correlation between IB and DV. Okay, this is two-tail. This one is two-tail. There is a significant correlation between IB and DV. It is two-tail hypothesis. Okay, and then if let's say you state the direction, for example, there is a significant positive correlation between IB and DV. This is one tail. Okay, or there is a significant negative correlation between IB and DV. Okay, this is two-tail. And sorry, this is one tail as well. Okay, again, how to choose your specific hypothesis. It depends on your literature review. Okay, it depends on the past study. What are the assumptions given by the previous scholar, or what are the findings based on the previous researcher. Okay. Okay, so for the first part, to describe the relationship, to describe the nature of the relationship. When we mention about the nature of the relationship, make sure you are able to describe two things: the direction and the strength of the relationship by using the Guilford rule of thumb or Cohen. Okay, so this is the cut-off point given by Cohen. Okay, if the value, the R value less than 0.2, it indicate the negligible relationship. If the value range from 0.2 to 0.4, the relationship considered low. Okay, 0.4 to 0.7 is moderate. 0.7 to 0.9, high relationship. Above 0.9 is very high relationship. Okay, so this one you should remember lah. Okay, and then based on Cohen rule of thumb, there are only 3 categories. Okay, so 0.1 consider weak relationship. Okay, 0.3 consider medium, and then 0.5 consider high. Okay, you can choose either one. Okay, but most of research or study they use Guilford. Okay. Biasanya kalau adalah debates mana satu nak kena pakai, but I thought because we are not statisticians, so we are just somehow practitioner and in which we want to use or interpret the value to implement further practical amendment. So you can just pick either one. Okay. Okay, so this is the scatter plot. I thought okay, quote this one ni. Okay, for A ni, this one is the positive relationship. Okay, between the IV and DV. Okay, the second scatter plot indicate the negative relationship because the flow of the dots is to ke bawah. Okay, and then the third table will be no relationship because the dots scattered everywhere. Okay, we cannot determine the direction of the dots based on the based on the dot showed in the third diagram. Okay. Okay, so this is again the magnitude of the R value. Okay. Yeah, Faiza. Okay. Okay, and then this is the 5 step of hypothesis testing in correlation. Okay. So state the hypothesis. This one dah lah. Ini sama je. So extract test statistic ni, okay, in this stage, okay, before we can extract the value, we need to be able to run the analysis in IBM dulu, okay, and then to run the analysis, this one you can use our data set, the one that I shared, data set class yang awal dulu, DCE 5951, okay, please use that one. Okay, but if let's say you want to do the hands-on based on your own data, it should be okay as well. Okay. Ready with your data set?
Ready, Doctor.
Ready, eh? Okay. So to run the analysis, you just click analyze, click correlate, and then click bivariate. Analyze, correlate, bivariate. Okay. And then after the bivariate correlation windows appear, you choose your IV and DV. Okay, you can choose more than one IV. You just include all the variables used in your study. Okay, we can do the the analysis at one shot. Okay, and then for correlation coefficients, please tick for Pearson. Okay, and then test of significance here, it depends on your hypothesis. If you state your hypothesis based on one tail, so click one tail. If it is two tail, click two tail. Okay, it depends on your hypothesis. And then check for flat significant correlation. And then you click the option. Okay, click option on your left side. And then you check for means and standard deviation. This one by default, it will exclude the cases pairwise. Okay, and then click continue. Okay, and then click OK. Okay, so this is the result. Okay, so there are only 2 tables, okay, for correlation analysis. The first one is descriptive, in which it will present your mean and standard deviation values. Okay, this one you need to report lah. By the way, this value also you can use when you determine the level. Okay, sepatutnya nilai mean ni sama yang masa kita analisis descriptive awal-awal dulu. Okay, it should be consistent, the mean value here. Okay, and then the main table that we want is this one, correlation table. Okay, Yeah, this table indicate a few values, but in diagonal. Actually, the top and bottom values actually similar. It is like mirror. Okay, when it comes to reporting, you just report either one. Do not choose both. Either you want to select apa tu, the one at the bottom ataupun dekat atas terpulang. Okay, after all they're similar. Okay, in terms of reporting, do not report everything. You need to be selective. Okay, what we need is actually these two things here. Okay, the Pearson correlation this Pearson correlation here means the R value. Pearson correlation here refers to the R value. Okay, so what we want is the R value here, the Pearson correlation here, as well as the significant here. Okay, but based on this table, you should aware with the symbol here. There's asterisk symbol here. Two symbol. Two flower, two flower. Okay, so two flower here indicates that the correlation is significant at the 0.01 level of significant. Okay, so if one say there are certain case that the flower is only one, asterisk is only one. So what if let's say the asterisk only one, meaning that your result is significant at 0.01 or 0.05. Okay, one flower indicate that the correlation is significant at either 0.05 or 0.1. Alamak, salah lah pula. One flower indicate that the result is significant at 0.05. Two flower indicate that the result is significant at 0.01. Three flower indicate that the result is significant at 0.001. Okay, you want me to repeat? Tak payah kan? Clear? Okay, so actually when you report, no need for you to report this one dah. All you need is this one, this R value and then the flower. So automatically we will understand that it is significant at 0.01. Okay? So clear? Okay, so we determine our alpha. Okay, and then we make decision. Okay, this is the general rule to make the decision. Okay, we reject our hash knot if the significant P is lesser or equals to alpha, and then we fail to reject hash knot if our significant P is larger than alpha. Okay. So in this case, since our significant P is 0.008 lesser than alpha 0.05, therefore we reject hash knot. Then we can say that there is a significant correlation between task-oriented copying and philanthropic behavior. Okay, so this is just the interpretation. This is not yet how we report. This is just how we interpret based on the finding. Okay. In terms of the relationship, because the R value is 0.341. Okay, since the R value is 0.341, so based on the Guilford rule of thumb, okay, we can say that the relationship is positive, and then the size is low. Okay, so it's fall under the second category. Okay, between 0.2 and 0.4. So it indicates the low relationship between task-oriented copying and philanthropic behavior. So in terms of presenting your table, you just present like this. Okay. In this case, because I have only one IV and then one DV. Okay, so therefore, I just report the heading for the column. Okay, for the column will be the heading for the row will be the variable and then philanthropy, and then for the column will be task-oriented copying, our IB. Okay, if you have more, meaning that you need to add lah. You need to add on your right side. Okay. So in here, see, I just present the R value and then the flowers. Okay, so then I locate the notes below the table. I just locate the note. So we can understand directly lah. Okay, no need for you to report the N value, the value 1, and then the alpha value as well. Okay. Okay, so So in terms of reporting, this is how we can report our finding. A Pearson product moment correlation analysis has been conducted to test the relationship or association between task-oriented copying with mean 4.43, standard deviation 0.51, and philanthropic behavior mean equals to 3.86, and standard deviation of 0.48 among Malaysian volunteers, and the results indicate that there is a significant positive correlation. Okay, there is a significant positive correlation between task-oriented copying and philanthropic behavior. So then we present our result in bracket, okay, in which the R value equals to 0.341 and then the significant value equals to 0.008. And then according to the Guilford rule of thumb, or you can also use the Cohen rule of thumb, the relationship considered low. If based on Cohen rule of thumb, the relationship considered weak. Low, weak, moderate, moderate. Okay. Okay. Any question regarding Pearson product moment correlation? Okay. I thought for MHRD students, they are quite good at this. Okay, what about students from another faculties? Are you okay so far with the Pearson product moment correlation?
Yes, doctor.
Okay.
It's okay.
Okay, now we proceed with Spearman rank order correlation or Spearman row correlation. Okay. So it is based on the rank order correlation. Okay, with the purpose is to determine also the relationship between two rank order variables. Okay. The requirement is either the DV is ordinal, both IV or DV are ordinals, or you also can have the continuous data for your IV and DV, but it is not significant. It is not normal. Okay, so for Pearson product, so Spearman row, you have two options to run this analysis. Either you have your IV and DV are ordinals, or you have your IV and DV are incontinuous data, but it is not normal. They do not meet the assumption of normality. Okay, then you can, because you cannot use the Pearson product moment correlation, but still you can test for the relationship by using Spearman rank order correlation. Okay. So similar to Pearson product moment correlation, we are going to cover two things. Okay, the descriptive part and the inferential. From the descriptive, we extract the R value and then we determine the direction based on the symbol located at the front of the value. Okay, and then we indicate the strength of the relationship based on Guilford rule of thumb or Cohen's rule of thumb. Okay, and then for the inferential, okay, it involves 5 steps. You state the hash note and hash A, report the R value, determine the alpha, decision and interpretation, and lastly present and report your results. Okay. So my suggestion for this course, do not I more prefer you to use the more practical way of stating your hypothesis. Okay, kalau boleh tak payahlah guna row S ke row ke, guna je yang overall statement of hypothesis. Okay, so this one saya skip lah. Okay, laju ni. Okay. Okay, for the descriptive, okay, you need to identify and extract the RS. So for Spearman rank order, we use the symbol RS, correlation coefficient S. Okay, referring to Spearman. Okay, and then describe the nature of the relationship between the two variables in terms of the direction, either it is positive or negative or no relationship. And then we indicate the strength of the magnitude of the relationship by using the Guilford rule of thumb or Cohen rule of thumb. Okay, this one saya skip lah, boleh laju ni. Boleh nak habiskan terus regression hari ni. Okay, this one similar similar to Pearson product moment correlation. The strength of correlation for Spearman rank order also range from -1 to +1. The plus minus just indicate the direction, but the strength of the relationship it depends on the value of the R itself. Okay. Okay, this is the Guilford rule of thumb. Okay, for the inferential, sama ni. Okay, and then for the hypothesis, okay, sama, similar. Okay, extract the R value. Okay, then to run the analysis in Ibm Spss, okay, you just are you ready with your data? Ready Tak nak buat pun tak apa sebab dah pandai dah. Okay, ready? Okay, if let's say you ready with your data to run the analysis, you just click analyze, correlate and bivariate. Analyze, correlate, bivariate. Okay, and then once this table appear, actually it's the step is similar with Pearson product moment correlation. It just in this case, once this window appear, you just tick for Spearman. Okay, earlier we tick for Pearson, but now Spearman. Okay, in terms of the test of significance, it depends on your hypothesis. Tick for flat significant correlation. Okay, and then you click option. Okay, by default nothing no need to tick for anything because when it is in categorical form, for sure you cannot get the mean. Okay, so that's why the button is inactive here because the both variable that I choose here are in categorical form. But if your variables are in continuous form, in continuous scale of measurement, okay, it will indicate here your means and standard deviation as well as cross product. Okay, but just in this case because it is in categorical form, that is why not possible for you to get the mean value. Okay, so then now click OK, and then this is the result. Okay. Compared to our Pearson product moment correlations result, the first table appear is the descriptive. But in this case, because it is not possible to get the mean and standard deviation, so that's why that table does not appear. Okay, so we have this result. Okay, so similar to Pearson product moment correlation table. So what we need to report similar. Okay, the significant value here and then the R value here. So the R indicate here there are two stars, there are two flowers. So the two flowers indicate that the result is significant at 0.1, 0.01 level of significance. Okay?
Doktor,
Yeah.
kalau asterisk tu, if the asterisk does not appear for the result, meaning not significant lah.
Yes, correct.
Alright, thank you.
But actually we can predict either our result is significant or not based on the value here. Based on the R value. Actually when we see the value is 0.71, it is quite strong. Right? If we refer to Guilford rule of thumb, the magnitude of the relationship considered moderate. Moderate ke high, right? Right? Moderate or high? I forgot. But based on Cohen, it is high. So for sure, when it is the value, the R value is 0.7, for sure, there will be significant, the result will be significant. But if the R value is 0.2 or below, okay, the result can be significant, slightly significant, or for sure not significant. If let's say the R value 0.1 pun biasanya no significant result. Okay, we check here based on the R value here. Okay. Okay, so we determine our alpha and then to make decision based on the criteria. Okay, so in this case, since the significant R, the significant value here indicated in the result tables is 0.000, in which it is lesser than alpha 0.05, therefore we reject hash not. Then we can see that there is a significant correlation between the level of education and salary. Okay, by the way, this one, after we just write like this, actually when to make the decision can be if let's say you are expert enough, when look at the value, when look at the table, you already can come up with the conclusion in your mind. Okay, but in terms of writing, we need to follow the alpha star. Okay, we need to report both the R and significant R. Okay, so based on the R, okay, the value is 0.710, indicates the positive relationship, and then based on Guilford rule of thumb, it is considered height correlation, height relationship. Okay, but based on sama juga based on Cohen pun dia rasanya height relationship. Okay, In terms of reporting, is similar with Pearson product moment correlation. This is the table should look like. Okay. When you're presenting your thesis or your dissertation, the spacing for all tables must be single spacing. Okay, ni saya cakap dekat Salim and for all of the student. Pak Salim dah kena bebel dah. Okay.
Doktor, doktor nak tanya sikit.
Ya.
In thesis yang reporting tu, table tu, is it compulsory kita nak letak yang notes kat bawah tu, yang S-string correlation is significant at the 0.01 level of ni,
Yes.
table tu?
Yes, Rahmi. By default, this is the format. Unless you do not have any asterisk inside your table, because this one actually indicate the what does it mean by two flowers, indicate by the two asterisk tu. Okay?
Okay. Alright, thank you.
Apa saya nak cakap tadi? Okay.
One more, doctor. By default in Spss, by default memang 0.05 kan? Dia punya alpha value.
0.05 macam mana? By default dia okay.
By default is 0.05 kan?
Okay, in Ibm Spss dia akan they will give you the result the lowest possible. If let's say your result is significant at 0.0001, so it will show you 4 asterisk. But for sure, if let's say you just set your significant value at 0.05, for sure once your result is significant at 0.0001, so automatically at 0.5 also it will significant.
Okay.
So macam tu. It doesn't matter lah, kalau nak tunjuk pun tak apa kata, tapi because in this table, kalau meaning that the lower the significant value, meaning that the strong the relationship. Itu maksud dia.
Okay.
Makin banyak asterisk tu semakin kuat sebenarnya hubungan antara IB dengan DB kita. Dia lagi bagus lah.
Okay, faham.
Lepas tu saya nak cakap. Sebelum saya terlupa. Okay. In this table, again I said that we just report the R value. We do not report the P value, because based on the notes that we locate below the table, we can only read what does it mean by the asterisk. Sebab tak nak sangat table kita jadi crowded. Sebab nanti banyak ni, if let's say you have more than 4 IV, so dia akan kembang ke bawah dan ke kanan. Okay, it will be in diagonal form. Okay. Ini soalan 1. Okay, so to present the result similar, okay, similar to Pearson product moment correlation. Okay, a Spearman rank order correlation analysis has been conducted to test the relationship between level of education and salary received among Malaysian volunteers. Okay, because in this study, the volunteers here not permanently work as volunteer. They just volunteer as a part-time, so they have their own commitment in their organization. Okay, so result indicate that there is a significant positive correlation between level of education and salary. So R equals to 0.710, significant value equals to 0.00, and then according to the Guilford rule of thumb, the relationship considered to be high. Okay, in terms of general formatting, this is how we should report, and how we should report. But okay, again, when we refer to the UPM's format, when you report the table, you need to when you report the result that you extract from the table, in which this table, okay, you need to mention the name of the table in text. You need to mention the name of the table in text. Okay, you cannot just locate your table without mentioning anything about the name of the table. Table 1 lah. Tak perlu lah state semua. Table 1 je nama tu. Mesti appear in your text. Okay, settle. So any question? Dah cakap dah, ni laju.
Doktor.
Yeah.
Kalau P value dia 0.053 or 0.055, dia significant ke tak?
Okay, point dia macam ni tau. When we present, sometimes I'm aware that all of us somehow eager want to have the data that is significant. Okay, so when your result the significant value of your study is 0.05 0.2, for example, slightly higher than 0.05. Okay, and then sometimes your R value pun around 2 something. Okay, it depends on you. Okay, to me, I still want to state that it is significant because it just slightly. Okay, so for the time being, I thought we can use the indicator. If let's say the value, the significant value is 0.05 below than 0.05. Macam ni. If your significant value 0.055, okay, if your significant value is 0.055, so we indicate that there is no significant relationship. But if the value is 0.054, you can still state that there is a significant relationship. Even it is statistically insignificant, but you still can say so.
Alright.
Sebab kalau kita bundakan pun dia still dapat 0.05, right?
0.05. Okay.
Okay, as long as it is below 0.054. 54 and 0.054 and below. If the value is 0.054 and above, statistically insignificant lah. Okay?
Okay.
Any other question?
Doctor, just another question. Like reading others articles, I found that they were determining variables level before they conduct the correlation analysis.
Again,
Is it they determine the level of the variable?
Okay.
Okay, before they do the correlation analysis.
Okay.
Is it a main requirement to do that, or just we can conduct the correlation analysis without having the variable level tested?
Dia macam ni, some of the researchers, because before they conducted the study, they already did the extensive review, okay, relating to which variables that strongly influence the DB. Okay, so that's why they managed to come up with that order. Okay, which is sama mana nak letak nombor 1, nombor 2, nombor 3 semua. They come up with that extensive review. But it is not compulsory. Okay, it's not compulsory. But if let's say you manage to come up with that kind of arrangement, it should be better lah. But kalau tak ada pun tak apa. Okay.
Okay, understood. Thank you, Doctor.
Welcome. So settle. Any other question from student from the other faculty? Tak ada. Okay. Shall we proceed to the next one? Regression. Banyak lagi ni. Tengok. Regression, chi-square mediation dengan moderation. Okay, so this topic now is regarding the simple linear regression and multiple linear regression. Okay. So these are the LO. Okay, to identify the types of analysis available for prediction and test for effect purpose. To determine the requirement to run the simple linear regression and multiple linear regression. And then run the analysis in Ibm Spss and then report the result according to the 6 APA style. Okay, so for the first one, simple linear regression. Okay, simple linear regression is an extension to Pearson product moment correlation, in which in Pearson product moment correlation, we just check the association between IB and DB. But in this regression analysis, we move one step further, in which we want to predict the future occurrence. Okay, the purpose is we want to determine the relationship, or we want to determine the influence between IB and DB. In general, we can state that there is we want to determine the relationship, but specifically we want to determine the influence, the effect or the influence of IB towards the DB. Okay, so that's why in this regression analysis we can specifically empirically prove the direction of the relationship between IB and the DB. Okay, and then another benefit is we can make the prediction equation. Okay, we can predict the occurrence of IB based we can predict the occurrence of DB based on IB. Okay, in terms of the requirement, okay, the scale of measurement for variables, both of your DV and both of your IV and DV must be in interval and ratio scale of measurement. Okay, and then these are the example. Okay, age, CGPA, ratio, and then interval. Okay, this one age is the continuous. You state your original age. Okay, and then CGPA, your CGPA either it is 3.4, 3.5. Okay, and then okay, for non-metric categorical IV, it must be transformed into dummy variable. Okay, this one if let's say you have you have categorical IV and then you need to transform your data set into a dummy variable. We just use two codes, 0 and 1. Okay. And then in terms of the number of dummy variables, okay, the class ni K equals to class minus 1. Okay. So saya tak nak tunjuk lah dalam ni, banyak sangat nanti. Okay. So for the assumption to apply regression, there are only two assumptions. The first one is the independent and dependent variables are bivariately normally distributed in the population, and then the case must represent a random sample from the population. Sama je macam correlation. Okay. Okay, so what to expect? Okay, the first you need to you are able to derive the regression prediction equation, make hypothesis testing, and based on the regression model. Okay, and then based on the regression model, you can report and interpret the value of R squared and R. R squared refer to what?
Amount of variance explained by IV.
Okay, cara we interpret, yes, but the name of R is coefficient of determination. Okay, R squared indicate the coefficient of determination. R here, capital R here indicate the correlation. Okay, in simple linear regression, R here similar to R in correlation. Okay, here apa maksud R squared itu adalah how we interpret, yes, it explain the variance in DV by IV, but the name tu adalah coefficient of determination. Okay, and then we come up with the slope. This one is based on the individual. Okay, slope here is actually referring to the individual contribution. Okay. Yeah, okay. Okay, and then slope ni it is based on the individual contribution, and this one that later that we will report the data and then the value. Okay, nanti saya akan explain lagi. Okay, and then the components of simple linear regression, there are two. Okay, descriptive and inferential. Okay, based on descriptive ni we are going to identify the B1 and B0 to insert in our prediction equation. Okay. Okay, and then based on that, we can interpret the R and R squared value, and then the hypothesis testing based on the regression model, and then based on the slope. Okay. But actually no need for you to no need for you to statistically calculate pun. You need to extract from the table sahaja. Okay, because everything will be given to you. Okay. For the descriptive, tak payahlah ni. Ni dah pandai dah ni. Okay, for the salah pula saya assume. Okay. By referring to this graph, okay, this one, this one, this one. Actually, when we come up with regression, actually we want to come up with the best fitted line. Okay, so what does it mean by best fitted line? Is the line that make sure that when the line that we insert, but then macam mana nak cakap? The best fitted line means that when we draw the line, so the dots or the data set that's scattered in our data set tu is cancelling each other. So the result will be 0. Okay? Clear? Boleh clear lah. Kalau tak clear nanti tanya PM to P. Okay? So we use the least square method to identify the line, but the line is called the least squares regression line, and then this method will minimize the sum square error. Okay, so the best fitted line ni it help us to reduce the error. Okay, so this one derive the equation. Okay, so to derive the equation, okay, you just need to identify the B1 and B0 values from the Ibm Spss output and then insert into this equation, this prediction equation y hat equals to B0 plus B1 x1. Okay, this one is just in the case that you have one independent variable. Okay, so B0 is equals to your apa tu y intercept the value where the line touch your y axis. So we call it as B0 or constant. Okay. And then B1 referring to the slope. Okay. Tak nak kecilkan benda ni dah tak nampak. Okay, and then interpreting the prediction equation based on a given prediction equation, you can indicate the influence of IV towards DB. Okay, then how to interpret is for everyone based on this value, based on y hat equals to 1.07, indicate the B0 plus 0.75x indicate the B1. Okay, we can interpret as for every 1 unit increase in x, okay, y will increase by 0.75 unit. Okay, this is how we interpret. Okay, and then we also can interpret the amount of increase or decrease in y is based on B1. Okay, then for the inferential part, okay, for the hypothesis testing model, okay, so what to expect, this one, state H0, HA, identify the test statistics, you mention your alpha, make decision, and lastly, conclusion. Okay, and then you can also report your effect size. Okay, this one, okay, so to state your hypothesis, okay, you can just state that there is the regression. This is for the overall model. This is for overall model, but basically, when you do your research, rarely found students state about the overall model. Okay, but this is the overall model. The regression model does not fit the data. Okay, this is for the H0. And then for the research hypothesis, the regression model fits the data at alpha 0.05 or 0.01. Okay. And then test 2, you after step number 2, you extract the test statistic, in which before that you need to run the analysis in Ibm Spss. Okay, to run the Ibm analysis, make sure you have your data right now. Are your data ready? Ready? Saya laju ni.
Ready.
Okay, good. Okay, to run the analysis, okay, now you click analyze, click regression, and click linear. Analyze, regression, linear. Okay, and then after this linear regression box appear, okay, now you choose your dependent variable and locate under the dependent variable column. Okay, and then for DV, for DV, locate your DV under the dependent variable column, and then for IV, you locate under independent variable. But this one for simple linear regression, we have only one IV. Later, I will go with multiple linear regression. Okay, and then now click statistics. Click statistics. Okay, under statistics, you check for estimates and confidence interval. Okay, and then model fit. Okay, and then click continue. And then you click option button. Okay, and then you include the tick for include constants in equation. And then click continue. And then click OK. Okay, but before that, if you're aware, the method that we use is enter method. Okay, actually in this method you can change. Some of researcher they may prefer to use stepwise, hierarchical, and so on. Banyak. It depends because some of studies, as what one of our friends asked just now, because after she read the journal, the researcher already locate the rank already rank their variables. They already rank their variables, right? That's why in here, because certain some studies they just want to check either the arrangement, the order of the variables to correct. So that's why they come up with the extensive review regarding the order or the rank of the variable. So in here, perhaps they may prefer to use hierarchical method to run the regression. Okay, and then the results will be slightly different lah, meaning that the result later will arrange according to the highest or the most dominant predictor to the lowest. Sebab in enter method we insert our variable together at one shot, so later the result also will be one shot. Okay, it will not be ordered in terms of the highest contributor to the lowest. No. Okay, it will not be in arrange. Okay. Okay. So this is banyak sikit lah. Ni lah dia punya penerangan sikit. Okay, the regression method ni dia ada 5. Okay, enter method, stepwise, remove method, backward method, forward method. Ada banyak. Okay, so this one in our case, because we assume that you do not have that strong background, so that's why you can just use enter method. Okay. Okay, so this is your result. Okay, so based on this one, the first table it indicate the method that we use. Okay, the R value indicate the R value, the correlation value. How we interpret this, it is similar with how we interpret the correlation coefficient value in Pearson product moment correlation. Okay, sama. Okay, and then the R square. Okay, the second one is the R square. Okay, the R square values or coefficient of determination value identifies the proportion of variance in DV accounted by IB. Okay, so in this case, we can say that 11.5% of variance in philanthropic behavior is explained by task-oriented copying. So this is how we interpret the R square value. Okay. Okay, and then based on the adjusted R square, okay, adjusted R square is actually the more accurate value for the sample drawn but it is considered an optimistic estimate for the population value. Okay, the adjusted R square is considered a better population estimate. So it depends, either you want to use R square or adjusted R square. Okay, you can choose either one. But somehow people say that adjusted R square is lagi accurate, it's more accurate. Okay, and then the second Anova table, this Anova table ni represent the overall model of our study. Okay, so based on this table, what we want to report is the F and significant F. Okay, so the F value here is 0.7. The F value is 7.631. The significant F equals to 0.008, in which lower than our alpha. Okay. Okay, and then the coefficient table. Okay, we refer to the second column here. Okay, task oriented copying. Okay, so this we specify to this row. Okay, so by the way, if you aware here, okay, we have unstandardized coefficients, B, standard error, and then we have the standardized coefficient. We have beta, T, significant T, and then confidence interval. Okay. So in here, for our unstandardized coefficient, this one we use to report this value, these two values we use to insert in our prediction equation earlier. Y hat equals to B0 plus B1 x1. That one, we just need, when we want to insert our data into that equation, we refer to this unstandardized coefficient. But in terms of interpretation, okay, when you want to describe the individual contribution, you need to refer to standardized coefficient beta. Okay, this one pun sama juga beta sebenarnya, tapi unstandardized, but this one standardized beta. Okay. So we refer to this one to interpret the contribution. Okay. And then the significant T and the T and significant T will provide the result for individual contribution or slope, either it is significant or not. So in summary, if you want to check your result is significant or not, you check here T and significant T. But when you want to interpret the contribution, you check for beta, standardized beta. When you want to insert the value into the equation, you refer to unstandardized beta. Itu dia punya penerangan. Okay? Okay, so summary to present summary Anova table to report your findings. So this is how it should looks like. Okay, you need to report the source, the sum square, the degree of freedom, mean square and F value. And tambah significant F kat sebelah ni. Saya lupa. Okay, significant F and significant F. Okay. So you need to report the sum square regression, sum square error and sum square total. Okay, degree of freedom. Okay, mean square error, F value and significant F. Okay, and then you set the alpha value. Okay, make decision. So in this case, based on the overall model. Tak ada, saya tak tulis Taklah, saya kira tu. Okay, so based on overall model, we can say that okay, the regression model fits the data at alpha 0.05. Okay. Okay, so this one additional summary ni apa dia ni? This one interpretation lah ni. Okay, the coefficient R square, the coefficient of determination R square ni, the amount of variance in Y explained by X. Okay, and then the value may range from 0 to 1. Okay, the lowest will be 0, the highest will be 1. Okay, the value of R square will always be positive. Okay, if you dapat negative tu something wrong somewhere. Okay, and then for multiple correlation coefficient, okay, the value indicate the relationship between X and Y. The value range from 0 to 1. Okay, and then the value somehow, okay, in here sometimes the R value here will always be positive even though the correlation is negative. So that's why to check for correlation you need to check for you need to run the Pearson product moment correlation. You cannot rely on the correlation coefficient here because sometimes you will miss the actual direction of the relationship. Okay? Clear? Clear? Clear lah tu. Tak ada soalan. Okay, so you can determine the effect size. This one you need to manually calculate. Okay, to calculate the coherence effect size, the equation is F square equals to R coefficient of determination divided by 1 minus R square. Okay, so you just insert the data, you just insert the value into the equation and then you will get the effect size. Okay, the earlier R square here based on the result ni. Mana dah? R square here ni, this one. Ni. Okay, this one, R square divide by 1 minus R square. So you will get the result. Okay, and then after you get the result, you interpret the value based on the coherence rule of thumb. This one. Ni. Okay, 0.02 indicate small effect size, 0.15 indicate medium, and then 0.35 indicate large effect size. Okay, so this is the additional interpretation.
Doktor.
Ya.
Yang kohon ni, large 0.35 kan?
Ya.
Ada maksimum ke tak ada?
Tak ada. If let's say your value is higher than 0.35, for example 0.6, so meaning that it's large lah.
Kalau let's say saya punya R square tu 0.86 R square 0.86. So 0.86 divide by 1 minus 0.86.
Betul.
Kan, betul. So maknanya dia punya figure tu akan jadi macam 5.6 6.2. Valid ke? Saya pun macam mana?
Ya, valid. Saya calculate. So for example, kita tadi 0.86 kan?
0.86 R square.
0.86. Sorry lah, kalkulator saintifik saya ada orang pinjam, lepas tu ulangkan lagi lepas PKP, so terpaksalah guna kalkulator yang besar bapak ni. 396 buat by 1 tolak 0.7396. Sekejap Oh, dia jadi 2.8 valid.
Oh, valid lah.
Sebab cosine square dia the value will range from 0 to infinity. Doesn't matter.
Oh, okay.
As long
Okay,
as it's more than 0.35, okay lah.
Okay. So maksudnya kalau macam tu dia punya effect size large lah
Large.
Betul. Okay. Thank you, Doktor.
Doktor, saya nak tanya. Doktor, jap.
Ya.
Kalau kita tengok yang dekat model summary untuk yang simple linear regression ni, dia punya R value tu, adakah dia akan sama dengan yang Pearson R value untuk Pearson?
Sama. The value will
Sama.
be similar with the value in Pearson product moment correlation. It just in case, okay, in case when you want to rely on because the result for regression, when you run the regression, it will come up with both prediction regression value and correlation R square and R tu kan. But okay, you will miss the actual direction of the relationship. Itu the direction tu, the simple tu, negative ataupun the positive, dia takkan tunjuk. Dia akan tunjuk positif je selalu kat situ. Okay, the value in a multiple linear multiple correlation result will always be positive. Dia akan tunjuk positif je. Yang negatif tu dia tak tunjuk. So you will miss that information. So that's why you need to run the Pearson product moment correlation to check for the association between your IV and DV. It's much accurate lah.
Tu yang tengok direction dia sama ada negatif atau positif.
Betul.
Okay.
Kalau kebetulan sama tak apa. Kalau kebetulan positif okay. But sometimes ada case hubungan negatif tapi because you read the result based on the multiple simple linear regression punya result, so you miss that information. Okay? Lagi soalan? Ada Okay, now we check for the slope. Slope, this one is based on the individual contribution. Okay, so what to expect? Also hypothesis testing, state H0, HA, and then extract significant T value, and then determine alpha, make decision, and lastly conclusion. Okay, so this one, sikit lah ni laju ni. Okay, to state the H0, okay, this one is mostly used by the student Okay, the hypothesis will be either there is no significant influence of task-oriented coping on philanthropic behavior to represent your null hypothesis, and there is a significant influence of task-oriented coping on philanthropic behavior to represent your research hypothesis. So basically in your research, most of the students use this one. Use your hypothesis, the research hypothesis lah to as their hypothesis. Okay, sedangkan kita nak reject the hypothesis that we want to check is actually this one, right? Okay lah. Okay, so then you need to extract the significant T value. This one after we run the analysis earlier, okay, we have the two table, Anova and then individual contribution table. Okay, so now to report this individual contribution, you need to check for the second table tu. Okay, report the T and then the significant T. Okay. Okay, and then report the alpha. Okay, and then lastly, make the conclusion. Okay, either you reject or fail to reject. But in this case, we reject the null hypothesis. Okay. So in this case, this is the illustration on how to calculate your effect size. Okay, you just insert the coefficient of determination value into the equation, and then you will get your effect size. Okay. Okay, this one is for the prediction equation. Okay, you extract the value from unstandardized beta. Okay, in which from the table our B naught equals to 2.457. Okay, and then our B1 equals to 0.316. Okay, so our prediction equation will be Y equals to 2.457 plus 0.316 x1. Okay, so if we illustrate based on graph, so this is how it should looks like. Okay, so 2.457 indicate the value where the straight line touch the y-axis. Okay. Okay, from the equation, this is how we can interpret. Okay, from 1 unit increase in X, okay, our Y or our philanthropic behavior will increase by 0.316 units. Okay, so best fitted line. Okay, this one, if let's say you want to come up with best fitted line, okay, this best fitted line is this line. This line. Okay, from IBM Spss, if you want to come up with this best fitted line, okay, again, you just click graph and then click legacy plot. Okay, click graph, graph, legacy dialogues, and then click scatter dot. In your IBM Spss, you click graph, legacy dialogues, and scatter dots. And then, okay, this scatter dot appear, betul? Correct? Appear macam ni ke? Okay, and then choose simple scatter. You choose simple scatter and then click define. Okay, and then you insert your IV and DV. You insert your DV and you insert your DV on y-axis, IV in x-axis, and then click OK. So you will get this one. Dapat tak? Salim, you get this? Dapat? Any problem?
Dapat.
Okay, then because this one is an the scatter plot without the best fitted line. To create the best fitted line, you need to double click on the graph. Okay, just letak je cursor mana-mana. You can locate your cursor everywhere, and as long as it is still on the table, on the scatter plot area ni, just double click and then your scatter plot tu akan activated. Okay, and then now you click the fit line. Dekat on your heading tu, dekat atas tu click fit line at total. Click this one. Fit line at total. Or you can also click the elements and then check for fit line at total. Okay, now it's appear like this. Dapat? So you have the equation should be similar with the equation that we have earlier. Y equals to 2.46 plus 0.32 star. This one meaning significant lah. This one meaning significant. Sama? Dapat? Okay, to interpret the R square and R, okay, R square we can interpret in terms of the variance explained by variance in DV explained by IV. So in this case, we can say that because the R square equals to 0.116, so we can say that 11.6% of variance in philanthropic behavior is explained by task-oriented copying. And then in terms of R value, multiple correlation coefficient of 0.341, we can say that there is a positive and low correlation between assignment scores. Salah ni. Suka hati je. There is a positive and low relationship. There is a positive and low relationship between PV and TOC. Okay. Okay, so in terms of reporting, this is how we should report. Okay. Okay, a simple linear regression was conducted to predict philanthropic behavior based on task-oriented copying. A significant regression equation was found. F equals to 158 degree of freedom equals to 7.631. Significant value equals to 0.008 with an R square of 0.116. Okay, prediction equation obtained from the result is you present your regression equation, and then y equals to philanthropic behavior and x1 equals to task oriented copying. Okay, according to the prediction equation, 1 unit increase in task oriented copying results is 0.316 increment in philanthropic behavior. Okay, further analysis of the effect size indicated that the effect size is small, so you present the effect size value. Okay, so in terms of the flow, make sure you report the overall model first before you report the individual contribution. Okay, you need to report the F value. Yeah, you need to report the F value and then followed by the T value. Okay, this is how to the APA presentation style. Okay, so you need to report. Please follow this format. I'm sure I'm not the only one at our faculty or our university that use this format. Okay, we report the model here, unstandardized coefficient. We report the unstandardized value, standard error, standardized coefficients, beta, T, and P. So our R value, R squared, F value, and significant F, we report below the table. Okay, we report below the table. We do not report these values inside the table. Okay, you just report below the table. Okay, Salim, again, please follow this format. Okay, any question regarding simple linear regression?
Doctor, question.
Yeah, sure.
When we talk about the reporting, is it compulsory for us to report also the plot? I mean, present also the plot instead of we just show the coefficient table. Is it compulsory to also show those plots?
Not compulsory, because as long as you already have your prediction equation, it should be okay, because the scatter plot is only represent saja, illustrate your prediction equation.
Okay.
Any other question? Okay, now this is the main topic lah. Most of the master HRD students waiting for. Okay, multiple linear regression. Okay, so it is the extension of simple linear regression, in which in simple linear regression we only have one IV. Meanwhile, in multiple linear regression we have more than one IV. Okay, and then the main purpose is we want to determine the relationship, okay, as well as we want to determine the effect or influence of IVs toward the DB. Okay, and then we want to make prediction equation of DB based on IV. So the objectives are very similar with simple linear regression. It's just in this case we have more than one IVs. So in terms of the requirement, okay, so the scale of measurement for the variables must be in interval and ratio for both IVs and all DBs. Okay, and then for non-metric categorical, IV must be transformed into dummy variable. Similar, this one. Okay, so in terms of the assumption, there are three, four. Okay, there are 4 assumptions. The first one is ample sample size for generalizability purpose. So make sure you have the ample number of sample size to run the multiple linear regression, because the main purpose of quantitative study, we want to apply, we want to make generalization from the data that we have to the overall population, and then make sure there is no multicollinearity issue, multicollinearity and singularity issue. Okay, singularity meaning that your variable really measured singularity means that your IV is not similar with the rest of your IV. Multicollinearity represent your IV may be similar to the other IV. Okay, so the outliers. Okay, and then the assumption of normality, linearity, homoscedasticity, and independence of residual. Banyak pula. Okay, and then the cases also must represent a random sample from the population. Okay. And then in terms of the sample size, it must be sample size, ample sample size to make sure the generalizability. This is based on the rule of thumb, 15 respondents per predictor. This is based on Steven. Steven indicate that if let's say you have 2 IVs, meaning that you need to have 30 respondents in your study. This is the rule given. And then another rule given by Tabani and Fidel, okay, n must be larger than 50 plus 8m, where m equals to number of IVs. Okay, you also can use this formula to determine your sample size. Okay, so I just present you with two formula to indicate your sample size. You also can use the G power, okay, G power software. So in terms of multicollinearity, it's referring to the relationship amongst your IV. Okay, it exists when IVs are highly correlated, meaning that 0.9 and above. Saya rasa 0.8 pun dah kira tinggi dah. Bukan rasa, memang betul. 0.8 and above considered you have multicollinearity issue. Okay. Okay, so R equals to 0.7, potentially to be deleted. At 0.7, relationship, if let's say you find out that the relationship between your IVs equals to 0.7, you may consider this variable to be deleted, because later your overall regression result will might be influenced by this value, by this case. Okay. And then singularity, it occurs when one IV is actually a combination of other independent variables. So possibly in your items, in your items too, it's similar. You have one IV that actually measures similar thing, because the items actually quite similar. Okay, so you need to be very very thorough lah when you prepare your questionnaire. Okay, very careful. Okay, so in terms of the outlier, multiple linear regression is very sensitive to the outlier, which is very high or very low score. Okay, outlier referring to the score that is significantly, not significant, obviously different from the majority. Okay, so that's why we call it as outlier. All IVs and DV should be free from the outliers, in which we can check from we can check for the outlier when we do our screening process in descriptive analysis. Okay, and then outliers for the DV can be identified from the standardized residual plot. Okay, this one is based on the box plot. Box plot, you can check for the outlier. Okay, the standardized residual values above 3.3 or less than 3.3 considered to be a potential outlier. Okay. Mana dah tadi? Allah. Ni. So meaning that you need for the outlier, when you run for your box plot, you need to check for any dots, okay, any dots that fall beyond the beyond the box plot tu, okay, if the value is 3.3 or less than 3.3, so you can consider it to be deleted lah. Okay. And then the normality. Okay, the residuals should be normally distributed about the predicted DV scores. This one you can check based on either scatter plot, either box plot, PP plot. You can use the Kolmogorov-Smirnov, Shapiro-Wilk, skewness, and kurtosis. You can use all that statistics to check for your normality. And then in terms of linearity, the residuals should have a straight line relationship with predicted DV score. So this one you can check from the scatter plot. Okay, you can check from the scatter plot when you come up with the best fitted line. So then meaning that you can prove the relationship of the linearity ni. Okay?
Betul.
Ya.
Yang linearity ni, maknanya kita kena check satu-satu dia punya best fitted tu. Kalau let's say kita ada 3 IV, kena check satu-satu.
Correct, yes. Tapi nanti saya tunjuk yang untuk multiple linear regression, we will go to that topic later.
Oh, okay.
Linear regression lagi. Oh,
Okay.
multiple linear regression lah kan? Oh, salah. Sekejap lagi saya tunjuk. Jangan risau. Okay. Okay, the residual should be, ni dah. Homoscedasticity refer to, mana pula. Okay. Homoscedasticity refer to the variance of the residuals about predicted DV scores should be the same for all predicted scores. Ni error lah ni. Okay, tak apa. We will go one by one The residuals ni refer to the differences between the obtained and the predicted dependent variables. This one, perhaps we predict another value, but what we have is another value. So residuals ni referring to error. Okay, so what to expect? You able to derive the regression of prediction equation, determine the best predictor, because in this case we have more than one IB, so we can compare which one is the best, and then we come up with the hypothesis testing, and then we make the regression. We check for the regression model. Regression model represent the overall result. Okay, based on that we can interpret the R squared value and R. Okay, and then from the slope we can check for the individual contribution. Okay, this one skip lah, itulah ni. Okay, ni sama, should be tak ada masalah lah kot. Okay, because in this case we have more than one IB, so we can check, we can compare lah which one is the best predictor. Okay, this one laju. Okay. This one sama, saya skip sahaja yang ni. Sama juga dengan simple linear regression tu. Okay, so in terms of prediction equation so because we have more than one IB, so we should expand lah. We should extend our equation lah according to the number of IBs that we have. If we have 4, meaning that we will have B1, our X ni, here we stop at 4 lah. Okay. So ni boleh laju lah sebab tadi baru explain. Okay, so interpreting prediction equation. Okay, when you are going to interpret the prediction equation, it is based on a given prediction equation, then you can indicate the influence of IBs on DB. Okay, this one simple. Okay, if let's say you have more, just add here. X1 here, X2, X3 and so on. Okay, for the inferential, this one laju lah. State H0 and HA, identify the significant F value, state your alpha, make decision, and lastly make your conclusion. And then report the effect size. Okay. Okay, to state the hypothesis for overall model sama macam in simple linear regression. Okay, ni sama. Extract. Okay, now we are going to run the analysis in Ibm Spss. So hopefully you are ready with your data set. Okay. To run the analysis, go to your Ibm Spss windows. Now you click the analyze, regression, similar, linear. Analyze, regression, linear. Okay, the analyze, regression and linear. Okay, and then after this linear regression box appear, now you choose your IVs and DV and then locate it under the appropriate column. So for DV, locate it under the dependent column. For IVs, locate it under independent column. Okay. Okay, and then now click ni lah yang tadi tu saya tunjuk tu, enter method, stepwise, remove, backward, forward. So in this case, we just use enter lah. Tak payah fikir banyak, enter je. Okay, now check for statistic. Okay, click the button statistics. Okay, now check for estimates, confidence interval. Estimates, confidence interval. Okay, and then model fit. And then descriptive, part and partial correlations and collinearity diagnostic. Okay, and then this one you can check for case-wise diagnostic, and we check for outliers outside 3 because last time 3.3 right? Okay, so we just locate 3 here and then click continue. Okay, then now click plots. Okay, click plots. Okay, you choose Z receipt, Z residual, Z receipt ni Z residual. Z residual located under Y, and then Z predicted located under X. Okay, and then for standardized residual plots, check for normality probability plots. Okay, and then click continue. Okay, done. And then now you click save. Click button save, do not save. Click button save. Okay, then you check for under the distances, you check for Mahalanobis and then Cooks. Mahalanobis and Cooks. And then click continue. And then under options, okay, make sure you check for include constants in equation. And then click continue. And then click OK. So this is your result. This is your result. Sama? Similar? Okay, so for the first level it indicate the descriptive. Okay, so you can get your mean value here, mean value and standard deviation from this table. Okay, and then now correlations. So correlation. So that's why in this the result of correlation should be similar when you run the Pearson product moment correlation. It just in here it will not locate the significant value. Okay, you have to check by yourself. Okay. So then another thing is the main purpose of correlation here is you if let's say you want to check for the multi-collinearity issue. So then you can check it from here. Okay, if the value of R equals 2.7, then you may indicate to delete that variable. Okay, so in this case, the R value here 0.341. Okay, the second one is 0.004. Okay, so I refer to this column. Okay, the R value, sorry, it's here lah. The R value for PB mean is 0.341. This one negative 0.138. Okay. Okay. So it's still below 0.7. So it indicates that there is no multi-collinearity issue lah. Okay, since the value below 0.7, so we indicate that we can say that we can conclude that there is no multi-collinearity issue in this data set. Okay. Okay, and then the next table is this the variables. This table we indicate the method used. Okay, and then model summary will present your R value and then R square. Okay. Okay, so in this case, based on the R squared value, we can say that 13.4% of variance in PB, in philanthropic behavior, is explained by AOC apa? Avoidance oriented copying, betul, yes. So meaning that in this case, earlier only 11 point something percent. So after we add another variable, okay, after we add another avoidance oriented copying, the overall model seems to be better. Okay, it's the AOC add another 2.2%. Sorry, AOC add another 2% in the overall contribution of our model. Faham? Earlier when we run the simple linear regression, okay, the R squared for the relationship between TOC and PB only 11 something. I forgot 11.4. But now, after we insert the AOC, now the model improved to 13.4. Okay? Okay, this one tak lah. Okay, so this is Anova Table. Okay, so this Anova Table will represent the overall model. Okay, what we need is the F and significant F value. Okay, so based on the model, based on the significant value of 0.016 lesser than 0.05, so we can say that our overall model fits the data. Okay, so based on this value, we can say that at least one of our IV significantly influenced the DV. Based on the overall model, we can say that at least one of our DV at least one of our DV significantly influence the DV. Sorry, we can say that at least one of our IVs significantly influence the DV. Okay, based on this model. Okay, so if we want to know which IVs between AOC and TOC, which one that is significantly influence the DV, we need to check for the next table, this table. We need to check for the coefficient table. Okay, so based on this table, okay, refer to the significant value. Yes, refer to the significant value. Okay, so again, the unstandardized beta will represent the standardized value we will use in prediction equation. Standard alamak, kenapa tak nampak ni? Okay, in which how we interpret the prediction equation is based on the how many unit increase. Okay, and then the standardized coefficient beta we will use to interpret the strength of the effect. Okay, okay, and then the T and the significant T we will use to make the decision. Either we can say that the influence is significant or not. So in this case, we can say that, okay, for the task oriented copying, since the T value is 2.757 and the significant value is 0.008, so we can say that there is a significant, yes, the significant influence of task-oriented copying towards the philanthropic behavior. But for avoidance oriented copying, the T value is negative, meaning that the relationship to negative, okay, negative 1.094, and then the significant value of 0.279 higher than 0.05. So we can say that there is an insignificant influence of task avoidance copying on philanthropic behavior. Okay, other than that, other than to determine the result based on significant value, we also can check for the confidence interval. If the zero located outside, the result is significant. If zero located inside the range, the result is not significant. So similar to the significant value result. So for the avoidance oriented copying, the zero located outside, so the result is not significant. For the task oriented copying, the zero located within the range of 0.086 and 0.543, so we can say that it is significant. Okay. Okay. So for the multicollinearity issue, to check for the multicollinearity issue, we refer to the table. This table lah, the correlation table tadi. Okay. So based on this table, okay, we refer to the table and then we can say that the R, mana dah? The R of R equals to negative 0.009 lesser than 0.70, and then there is no issue of collinearity. Okay, most of the values, most of the value indicate that the value is lesser than 0.7. So we can refer to the this is the first way to check for the multicollinearity, meaning that we just compare the value inside here with the we compare it with the cutoff point of 0.7. So tadi saya rasa earlier I use this value, right? So I mistakenly, sorry for that. When you are going to check for the multicollinearity, make sure you check the R value for the relationship between IVs. So in this case, we have two IVs, task oriented copying and avoidance. So the R value is negative 0.009. So this one, the R value. Okay, not this one, This one. Okay, the relationship between IVs. So in this case, the relationship between IV, the R value equals to negative 0.009 lesser than 0.7. So we can conclude that there is no issue of multicollinearity. Okay, so meaning that our data set, our results are valid. Okay. And then the second one is we can refer to the coefficient table. The coefficient table, if you're aware, we get it from here. Ni. Ni, this collinearity statistic. Okay, we refer to this table. Okay, based on the table, okay, based on this table, okay, that if the tolerance value lesser than 0.1, if the tolerance value ni less than 1, it indicates the high multiple collinearity with other variable. Okay, so ataupun equals to multi-collinearity issue. Okay, so in this case because the tolerance value is 1, so there is no multi-collinearity issue. If the tolerance value lesser than 1, yes, there is a multi-collinearity issue. If the value is 1, there is no multi-collinearity issue. Faham eh? Okay, so for VIF, variance inflation factor, how to calculate it is equal, this is the equation 1 divided by tolerance. Okay, in which it is inverse of the tolerance value. Okay, the VIF larger than 10 equals to multi-collinearity issue. Okay, so you just insert the VIF value here into this equation, and then if the VIF value larger than 10, okay, larger than 10, then it refer to the multi-collinearity issue. Okay, so in this case there is no, based on the two statistic, based on the VIF tolerance and correlation value, there is no multi-collinearity issue. Okay, so far so good. Okay, lagi ni ya.
Just one question. I'm running my data lah. So kalau based on my because nak tengok yang multi-collinearity tadi kan. Kalau based on correlation table, saya punya value for R between IV is 0.7, meaning potential to be deleted lah kan?
Betul. Betul?
Okay, but then kalau tengok balik pada coefficient table for the tolerance value, I got tolerance value, right? So I got 0.456.
Memang betul lah tu. Multi-collinearity. Because if the value, the tolerance value is 1, there is no multi-collinearity issue. If the value is less than 1, multi-collinearity issue. What the thing that I can suggest, perhaps you can go back to your data screening process, check for the outlier. Before you delete the variable, perhaps you can check for the the outlier or extreme values. Check dulu untuk that one. Boleh?
Outliers meaning we have to exclude those cases yang cause that outliers lah kan?
Yes. Pak Izzah yang tanya kan?
Yes, saya.
Pak Izzah, okay. Before you make any deletion, make sure you have you copy that file. Okay, make sure you keep your original file. Jangan copy daripada original file You keep the original.
Because I did actually the data screening, so I've excluded a few cases and everything. My outliers is still there having problem because when looking at fairness punya ni procedural dengan distributive, memang in literature it is said to be very much related, these two.
So itulah, itu akan masalah tu. Itu memang akan masalah lah kalau dia memang related to, meaning that the item inside it is actually measuring similar thing.
It is some way related to each other, meaning in terms of procedures it is not that much not that much contribution to the satisfaction, as long as the outcome is good. That is based on literature lah.
Maksudnya kena justify lah tu. Kalau tak nak delete tapi kena justify lah. But tadi kalau less than 0.7 tu, less than possible to be deleted, right? Kalau 0.9 tu, 0.9 tu confirm kena delete. Kalau rasa nak proceed boleh juga, tapi later in your limitation perhaps you highlight that thing. Dalam bab 5 kelima just highlight. Sayang kan nak buat penat buat research. Faham, saya faham. Buat research macam tu lah. Okay, so next is collinearity diagnostic. So based on this table, okay, we refer to the condition index. Okay, based on the condition index, if the condition index greater than 15, it indicates a possible problem. Okay, and then if let's say the index greater than 30 suggested a serious problem with collinearity. Yang ni untuk check for linearity lah juga ni. Okay. So apa tu, greater than 15 indicate a possible problem, not necessary to be deleted, but if let's say the value is 30, meaning that you are strongly suggested to delete that case. Okay. Okay, so another thing is you can do it based on, you can check the outlier, normality, linearity, homoscedasticity, independence of residual based on the PP plot. So if the points lie in a reasonably straight diagonal line from bottom left to top right, this suggests no major deviations from normality. This one is based on Scatterplot. Okay. Based on the Scatterplot, if the residual roughly rectangularly distributed with most of the scores concentrated in the score along the point zeros, and then we can say that it should be okay. Okay. Nah, ni dia punya value lah, cut off point. If the value more than 3.3 or less than negative 3.3, considered to be an outlier. So kalau kita tengok in this case, so the value range still range between -2 and 2. So still there is no outlier lah. Okay, so another thing is Mahalanobis. So if you run, okay, if you aware in your data set, in your variable view, you will have a new variable mah, and _1. So this one referring to Mahalanobis distance. Okay. Okay, so for the step, okay, you can determine how many independent variable will be included in your multiple regression analysis. For example, in this case, we use 2, and then we find this value in one of the shaded columns. So we find the value. This is the formula given by Tabani and Fidel. Okay, and then, okay, so in this case, okay, if you're okay, in this case our independent variable is 2. Our independent variable are 2. Okay, so the cutoff point that we can refer is 13.82. Okay, so this is our cutoff point, 13.82. So this one, no. Okay, so we refer in your data set. Okay, in your data set, you refer to column mahal distance. Okay, and then you refer for maximum value. Okay, you refer maximum because this value, it will summarize from your data set. Okay, it will locate the minimum is 0.019, the maximum is 7.978. So this value is still lower than the critical value of 13.82. So we can say that there is no issue of outliers here. Okay, there is no issue of multi-collinearity issue. Should be okay. Okay, and then another thing is you also can check by case. If you are rajin lah nak check, okay, you can choose you can sort case. Okay, you can sort case based on the Mahalanobis square, and then you check for the descending or descending ni. Okay, and then click OK. Okay, and then it will arrange your data set like this. Okay, sama lah, sepatutnya sama. The value should be similar with the one summarized in this table. Ni okay. Ni sama. So it will locate the highest value of Mahalanobis square, Mahalanobis distance at the top. Okay. So similar to the Cook's. Okay, similar. This one, okay, for Cook's, the cutoff point is 1. If the case with values larger than 1 are a potential problem based on Tabani and Fidel. So based on our minimum and maximum, okay, the maximum is 0.089, lesser than 1. So we can say that there is no issue of, there is no problem in our data set. Okay, so this is similar step. If you want to check the value based on your data, okay, you can check individually by clicking your data and then sort case. Okay, from you choose the descending order. choose a descending order to arrange your data set. Okay, so it should be like this lah. The value should be similar with the summary table. Okay. Okay, so we are done. So since there is no problem, then we can proceed with extracting our value, our report. So now we set our alpha 0.05 on 0.01. Okay, and then we make the decision and lastly conclusion. Okay, so in this case, earlier our significant F is lesser than alpha, then therefore we can conclude that our regression model fits the data. Okay. So this one is the additional interpretation that you need to include in your report, the R square. So basically we just report R square, no need for you to report R pun. Okay, just report the R square in for multiple linear regression. And then for the effect size, you need to follow the similar equation, F squared equals to R squared divided by 1 minus R squared. Okay. Now we are done with the overall model. Okay, for the slope or for the individual contribution. Okay, similar, there are 5 things to be expected. State hash not hash A, extract the significant T value, determine the alpha, decision, and lastly make conclusion. Okay, this one skip lah, just skip lah. Okay, so in terms of the hypothesis, okay, you can directly state that there is a significant influence of task-oriented coping on philanthropic behavior. So for the slope, you need to state the hypothesis individual according to your according to your IVs lah. If you have 2 IVs, meaning that you need to have 2 IV, two hypothesis. If you have 3, then you need to have 3 research hypothesis. It depends. Okay, and then the extract value from the earlier result. So in this case, the T value for the task-oriented copying equals to 2.757. The significant T equals to 0.008. The alpha we set it as at 0.05. So we make decision. So since our significant T 0.008 lesser than alpha, therefore we reject hash not. So then we can conclude that our task-oriented copying contributes significantly towards philanthropic behavior. So this is the conclusion. Literally, okay. So then we calculate for our effect size. So after we insert the value of R squared inside our inside our model, so the value equals to 0.155. So considered medium effect size according to Cohen's rule of thumb. Okay. Okay, so when we insert based on the prediction equation, okay, we insert the value B0, B1, B2. This is under unstandardized, unstandardized beta. We locate under into the equation. Okay, Y equals to 3.0505 for B0 plus 0.315 X1 minus 0.160 X2. This one is AOC, avoidance oriented copying. Okay, so we can illustrate like this. Okay, and then we from the equation we can interpret it as for every 1 unit increase in task oriented copying, philanthropic behavior will increase by 0.315 units. So we can conclude this based on the direction of the relationship since it is positive. Since it is positive, so any 1 unit increase in X, Y also will increase by certain units lah. Okay, and then for the avoidance oriented copying, from the equation it is indicated that there is a negative relationship. So we can conclude that for every 1 unit increase in avoidance oriented copying, philanthropic behavior will decrease by 0.16 units. Okay. Okay, so for R square equals to 0.134. So we can say that 13.4% of variance in PB, in philanthropic behavior, is explained by TOC. Sorry, this one is explained by TOC and AOC. Okay, this is the overall contribution. Okay. Okay. Okay, in terms of reporting, Okay, this is how to report. A multiple linear regression was conducted to predict a philanthropic behavior based on task-oriented copying and avoidance-oriented copying. A significant regression equation was found. Okay, F value, the degree of freedom equal the in bracket degree of freedom equal the F value equals to 4.427. Significant P equals to 0.016 with an R square of 0.134. Okay, prediction equation obtained from the result is y equals to 3.05 plus 0.315 minus 0.16. Okay, x2, where y represent the philanthropic behavior, x1 task-oriented copying, and x2 avoidance-oriented copying. According to the prediction equation, 1 unit increase in task-oriented copying results in 0.315 increment in philanthropic behavior, and 1 unit increase in avoidance-oriented copying will reduce philanthropic behavior by 0.16 unit. Okay, further analysis on effect size indicated that the effect size is moderate. Itu sahaja. Okay, in terms of the, by the way, this is not the, this is the standardized format, but you can arrange accordingly as long as all the result, all the values, all the necessary value being reported. Okay, and then even the way you present the R square, you can also present in terms of the percentage, meaning that there are it has been reported that 13.4% of variance in philanthropic behavior has been explained by both task-oriented copying and avoidance-oriented copying. Okay, this is how to interpret je. Okay, and then in terms of table representation, this is how you should present. Okay, if let's say you use the abbreviation, make sure you locate the note below the table. This one, TOC, AOC. Sepatutnya ada note lah kat bawah ni. Okay, in terms of the table, this is how you should present. Okay, you need to present both model for constant, TOC and PB, and then AOC and PB. And then you present the unstandardized coefficient based on B and standardized error, standardized coefficient, and then T and then P value. Okay. Okay, done. Any question?
Doktor.
Ya.
So antara IV tu kan macam mana kita nak tahu yang mana lebih dominan, lebih mempengaruhi?
Lupa. Okay, if let's say
kita nak tengok table mana?
Table mana? Okay, if let's say you want to add more elaborations into your explanation, you can refer to this table. Mana dah? Saja. Kita pergi yang overall model tadi.
Yang standardized beta value tu kot kan?
Yes.
Mana yang lebih tinggi biasanya kan?
Actually yes, this one. When you want to come up with the conclusion which one is the dominant predictor, check for the standardized beta coefficient here. Okay, check for this one and then check for this beta ni. Okay, so we check this one. So since in this case our beta value for task oriented copying is 0.340, larger than negative 0.135 ni, so we can say that we can conclude that task oriented copying is the most dominant predictor in this model. Macam tu.
Okay doktor, kalau yang negatif tu, yang dalam tu 0.135. Kalau negatif 0.5, dia lebih
maksudnya in that case meaning that value should be the most dominant predictor lah.
Tapi dia
negatif.
But the negative relationship lah.
Yes, correct. So negative or positive to just indicate the direction of the relationship. It does not represent the value of the relationship. So if you want to indicate the most dominant, you refer to the value, not the symbol.
Alright.
Okay. Lagi ada question dah? Nak habis dah ni?
Doktor, kalau F value, kalau effect, sorry, kalau
tak apa.
Besar, sampai 2 boleh ke doktor? Logik ke?
Logik. So no worries. So because the value will range from 0 to infinity. So no worries.
Oh, okay. Thank you doktor. Sorry.
Jangan confuse. Okay je. Okay? Aisyah kena tadi.
Doktor, nak tanya. Untuk variance tu, for multiple linear tu, we just report yang overall contribution kan? No need to report yang individual contribution, betul tak?
You can report both, then you can also report either ones. But when you, if let's say you report the overall, it indicate the overall contribution lah. But when you report individual beta, actually indirectly you already report the when you report the beta here, you also will indirectly report the individual contribution.
Okay.
They actually sama. The way you interpret the beta, similar with the way you interpret the R square. Okay.
Okay.
But from the B, when you just mention about B, okay, you can see that 34% of variance in that model, okay, has been explained by task-oriented copying. So besar juga ni.
Okay, okay.
But 34.0% ni is from the 13% tu tak? Faham?
Faham.
Macam ni lah, saya try explain lah. Mungkin for those who might not clear, saya try explain Macam ni, based on the overall model, okay, your R square is
Dia just nak measure mana influence more kan, predictor yang IV yang influence more, tapi value strength of correlation tu based on Pearson punya R tu kan, doktor. Tapi yang multiple regression ni untuk tengok between those IV tu yang mana influence have more atau larger influence to the DV kan ke? Saya faham tu. Agaknya lah.
Sekejap saya tunggu habis azan. Sekejap Dah habis dah? Tak tunggu habis azan. Okay, dah. Okay, so macam ni. Okay, so untuk overall, first saya explain this one dulu Yang for not this table. Okay, not this table. R square. Okay, this table. Okay, so if you aware here, our R square value is 13.4. Okay, 0.134, so 13.4 lah. Okay, so this one is indicate the percentage is based on 100 13.4% of variance in philanthropic behavior has been explained by this two IB. Okay, based by avoidance oriented copying and task oriented copying. So when you elaborate this table, this beta value table, this one, okay, 34.0% is based on that 13.0%. Okay, 0.34 ni here ni is based on that 0.134. So 34% out of 13.4% tu sebenarnya kita jadikan dia sebalik 100. So 34% out of that 13.4 tu has been explained by task oriented copying. And yes, 13.5%, another 13%, 13.5% has been explained by avoidance oriented copying. Another berapa around 50%. Another 50% to actually another variable or error. So sepatutnya the total of this beta will represent the 13.4 lah kan, sepatutnya kan. Maksudnya kat sini sepatutnya when we add up the beta value for both task oriented copying and avoidance by oriented copying, the values should be 100 if let's say there is no error. But sebabnya ada error, so that's why the value is not 100% dekat sini. Faham? Okay, in addition to that, okay, the standardized beta ni will indicate the direction of the relationship as well. If in your correlation, if in your Pearson product moment result, it indicate that the negative, there is a negative or positive correlation, the result kat sini pun sepatutnya sama. Okay, the result should be similar. Kalau tiba-tiba lain, something wrong somewhere dengan your dataset or your analysis. Okay, another thing is if the result is significant in your regression model, for sure in your correlation the result will be significant. Okay, if your result, if the influence if the result for the regression model is significant, for sure in your correlation the result also will be significant. But if there is a significant relationship in correlation, not necessarily the result will be significant in regression. Okay, because the regression is the higher level analysis compared to correlation. Okay. So saya jawab tak soalan tadi tu? Soalan siapa dah tadi tak ingat dah ha. Saya jawab ke? Ke ada lagi benda nak tanya? Is there any more confusion? Clear Clear. Okay. So actually we are done for this topic. So I thought you can, for those who preparing their final report for dissertation, okay, I thought it's going to be helpful, hopefully. Okay, so any other question? Soalan lagi? Ada soalan lagi?
Takut.
Doktor, last. Untuk yang collinearity dynastic tu, kan, kalau kita kena tengok condition index tu, kalau more than 30 tu kita nak buat apa?
More than, which one? Which one?
Condition index untuk collinearity dynastic tu.
Okay, kalau dia more than 30, maksudnya kena delete lah. Dia possible untuk delete lah. Maksudnya there is issue in your dataset. Dia ada masalah. Either it is tak normal ke, ada dia macam ada multi collinearity issue ke. So it is possible, it is suggested for your variable to be deleted or to be excluded from the analysis. Okay, kalau pada saya, sebab kita penat-penat buat research kan, kalau tak nak delete, then you go back to your screening process. Okay, make sure there is no outlier, extreme value, then you run again the analysis. Tapi you kena start from zero lagi lah, kena pergi balik dekat macam tu lah. Penatnya buat research, nak datang dengan sikit finding tu, dia punya proses tu punya panjang. Rasalah apa yang kami rasa. Rasakan.
Aduh, kena ubah macam ni.
So dia kena patah balik, buat balik run balik the normality, check balik the normality tu. Kalau perlu buang, then buang dulu, you delete the variables, you omit the variable, then you need compute again the mean, then run balik analysis. Normality kalau dah normal, okay, only then you can proceed to the next stage. Dia macam
kena extend satu sem lagi, doktor.
Apa? Janganlah extend, boleh tu buat. Dah belajar ni, nanti pejam mata je dah boleh analisis dah ni. Dah tak payah. Sebenarnya statistik bila guna software ni dah tak senang. Yang susah tu manual calculation je untuk kita faham. Tapi once you already have that understanding, it should be very easy. It's very handy lah. Kan?
Doktor nak delete variable apa, doktor?
Delete variable apa? Basically kita akan delete IV. Kita tak akan delete DV.
Akan delete IV keseluruhannya.
Maksudnya dia instrument tu tak payah guna ke?
Bukan, that's why you need tengok dulu dekat correlation table tu.
Okay.
So correlation table tu you need to check which IV actually yang has a strong relationship tu. IV dengan DV. So kalau maksudnya you need to check that pair. Kita tengok macam tu dalam case, for example dalam case saya ni, for example the AOC and TOC ni has the significant value of 0.9 for example. So I need to check these two variables. Either mana satu nak delete tu terpulang pada researcher. you need to check dulu these two IVs. In terms of the items, you need to, in terms of the operational definition, check balik ni berbalik kepada semula kepada you all punya instrument.
So maksudnya delete item lah doktor. Soalan tu lah delete item yang okay.
Yes, possible delete item then make sure item tu tak ada yang repeated inside that two IVs. Ni berbalik semula kepada validation process. Nampak tak? Dia berkait.
Faham. Okay.
Validation process dulu kalau you all properly follow the procedure, okay, meaning that you have a proper operational definition, and then based on the proper operational definition tu, you have the proper procedure of validating your instrument. You have the expert, you have the opinions. You run the analysis letter. Sebenarnya takkan ada masalah ni. Dia sebenarnya ada masalah validation tu. So that's why bila ada isu kat sini, ada siapa gosok gigi tu? Okay, if you have that problem, basically the reviewer will check for your instrument. Basically most for the project paper student dia takkan ada masalah ni lah. Basically for the master science. Biasanya untuk project paper student jarang, so far tak ada lagi lah tu examiner suruh collect data lain. Examiner pejam mata je biasa, habis-habis pun kena tengih time presentation tu je lah.
Doktor, jadi apa beza yang multicollinearity dengan validity yang kita dah buat before tu?
Dia sebenarnya multicollinearity ni dia just double check balik. Dia balik validity.
Ada motif betul lah gosok gigi time ni.
Gosok gigi pula.
Orang baru bangun kot.
Okay.
Ya, pemut.
Validity earlier tu maksudnya itu the process to prepare our questionnaire. Okay, tapi dia akan berkait sebab the result here will represent your item, so dia akan memang akan nampak balik. Benda ni akan berkait-kait. So that's why kalau let's say you already follow the proper procedure when you prepare the validation process, when you prepare the instrument tu, you shouldn't have this issue bila when you are at data analysis stage. Kalau biasanya kita ada masalah tu, maksudnya masa kita buat data, when you prepare your instrument dulu tu, ada benda lah banyak yang you skip. Itu masalahnya. Itu isu dia yang dia akan berkait. Maksudnya reviewer ni dia akan boleh predict apa yang you all buat masa you prepare your questionnaire tu. Tersenyumlah kalau kita faham. Okay? Dia sebabnya memang benda ni dia akan berkait. Kita nampak the process tu independently macam tak berkait, tapi sebenarnya at the end of your research, when you prepare your result and so on, barulah you figure out that it is actually the interrelated process. Okay?
Ajim diam tu doktor, saya risaukan dia tu.
Ajim okey tu. Ni siapa ni?
So doktor kalau dapat 33 tu condition index tu kira halal lah, bunda 30 kan?
Boleh lah. Dah dekat-dekat sikit tu boleh lah pejam mata. Kalau lain lah kalau tiba-tiba 50. Kalau dekat-dekat tu boleh pejam mata. So no worries lah. Kita orang tak adalah jahat sangat.
Alright.
Sebenarnya kalau you all laki dapat examiner yang tak perasan benda tu, laki lah you all. Masalahnya kalau dapat macam saya ke, Dr. Ashraf ke, itu je lah. Dapat orang kuali tak apa, macam dapat Dr. Musyik ke, tak apa. Kalau dapat orang yang berkira macam saya, kenalah macam tu. So doa lah tak percaya. Okay? Okay? Faham? Ada lagi soalan? Faizal saya jawab tak soalan tadi? If the hypothesis mentioned to measure the, okay, should that be a problem? Okay, if the hypothesis is mentioned to measure the correlation between each IV and EV, should tak ada masalah Faizal. Okay, should that be okay because we just want to study the relationship. Okay, basically multicollinearity ni it happen when we check for the multicollinearity issue when you are interested to test for the influence. Kalau just correlation biasanya tak payah lah. Okay, tak payah. Sebab influence ni nak tengok nak tengok kita nak come out dengan prediction equation. So that's why we need to make sure that there is no error. Kita nak reduce the error tu walaupun 100% we cannot eliminate the error 100%, but we reduce a certain number lah. Okay, but if let's say your study just stop at correlation, no need to proceed with multicollinearity testing. Okay.
Tak payah discuss benda tu lah doktor dalam paper kan? Nak selamat.
Ya, tapi kan Fairuza, actually to me, why not you just proceed with your finding, because even though both of you IVs tu are strongly related to each other, tapi macam saya kata tadi, it just dekat point 7. So point 7 they just suggest you kita boleh consider untuk delete.
Boleh lagi.
But to me, you can proceed, but at least in your limitation, and then you can state that mungkin ada error kat situ, and then perhaps in your recommendation you may suggest that future study should review again the construct for these two variables, so that it is actually represent different thing. Banyak juga benefit dia kan nampak macam tu, dia ada banyak benda lain. Tu pasti je buat. Okay?
Okay, thank you doktor.
Okay, so any other question guys? Tak ada, nak stop ni, cek nasi ni. Makan. Okay, tak ada Okay, so so that's all for today. Thank you guys for joining me today. So hopefully next week we just continue our lecture on Tuesday at 2 at 2:30 at 2:30.
2:30.
At 2:30 as usual. The next topic we are going to cover on chi-square. Okay, chi-square. Perhaps we can complete everything by next week, and then next another week it will be related to mediation and moderation. Okay, mediation and moderation in SPSS only. Okay. So that's all for today. Thank you guys.
Okay, thank you doktor.
Assalamualaikum.
Thank you, doctor.
Thank you, Doctor.